Example number 3. Find the solution of x squared plus 3x minus 5 over x minus 2 less than 1. Step 1. Represent the inequality in standard form. So, our original inequality is this. We need to transpose 1 the other side. That will be minus 1. Now, the LCD will be x minus 2. So, we need to multiply x minus 2 over x minus 2 for negative 1. And that will be x minus 2 over x minus 2. So, copy this rational expression minus x minus 2 over x minus 1. That is 1 times x is x. 1 times negative 2 is negative 2. Copy the denominator. Combine similar terms in the numerator, that is x squared plus 3x minus 5 minus x plus 2. X squared has no similar term, so just copy x squared plus 3x minus x is 2x. Negative 5 plus 2 is negative 3 all over the LCD x minus 2 less than 0. So our p of x is x squared plus 2x minus 3. Since the highest exponent is 2, we need to factor it. And the factors will be x plus 3 and x minus 2. Now, to factor that one, you find factors of negative 3 whose sum is 2. So those are 3 and negative 1. So 3 times negative 1 is negative 3, and 3 minus 1 is 2. For q of x, that is x minus 2, the denominator. Step 2, get the meaningful numbers by using p of x and g of x. So for p of x, it has x plus 3 and x minus 1. Therefore, the meaningful numbers are negative 3 and positive 1. Q of x will be x minus 2, that is positive 2. So we have 1, 2, 3 meaningful numbers. Next is to test the 3 meaningful numbers if they're part of the solution. So using the inequality x squared plus 2x minus 3 all over x minus 2 less than 0, the standard form of the inequality, we test negative 3 by substituting it to the value of x. And we get 0 over negative 5. Simplify it, we get 0. And 0 is not less than 0. So this statement is false, meaning to say negative 3 is not part of the solution. The next meaningful number is 1. The same procedure will be done for the meaningful number 1. So we have a value of 0 less than 0 also. This statement is false. 1 is not part of the solution. The third meaningful number is 2. Substituting it to the standard form inequality, we get undefined answer. And undefined is not less than 0. So 2 is not part of the solution. Step 3, we're going to divide the number line from the given meaningful numbers. So our meaningful numbers are negative 3, 1, and 2, and it divides the number line into 4 intervals. Those are less than negative 3, between 1 and negative 3, between 2 and 1, and greater than 2. Next step is to solve the test values for x in f of x equals x squared plus 2x minus 3 all over x minus 2. As you can see, I have a table prepared. These are the 4 intervals, and we're going to test the values using negative 4 under the first interval, 0, 1.5, and negative 3. So the value of f of x, by substituting negative 4 to f of x, we get negative 5 over 6. The sign of f of x is negative, so meaning to say that this interval is not part of the solution. The next interval is less than 1 but greater than negative 3. So our test value is 0. We got 3 over 2. our sign value is positive. So this interval is part of the solution. The next interval has a negative answer, so this is excluded. And the last is x greater than 2, our answer is positive 12. So meaning to say x greater than 2 is part of the solution. Now, if you want to ask or know how did I get negative 5 over 6, I have here an example. Thus, negative 4, because the value of our x is negative 4, just substitute it to f of x, we get 5 over 6 or negative 5 over 6. Same procedures will be done for the 3 intervals. Then you will get the same answers. And the last step is our answer in interval notation. So since these 2 intervals are included as our solution and negative 3 and 1 are not part of the solution, then we use an open parenthesis starting at negative 3 to 1. It closes at positive 1, union of positive 2 to positive infinite. So we also use close and open parenthesis since our meaningful numbers are not part of the solution.